Welcome to AGPR201, Basic Soil Science. Today we're going to be doing the first laboratory for this course, which is called Soil Morphology. In this laboratory, we're going to be learning several things about basic physical properties of the soil. One of the characteristics which is important to soil is its texture. Now, we've defined texture as the percentage of sand, silt, and clay in a soil, but when you feel a soil or try to determine texture by feel, you have to do this through a procedure whereby you're estimating that percentage of sand, silt, and clay. If we were able to determine exactly the percentage of sand, silt, and clay in a soil, we would then go to a textural triangle, which is in your lab handout, and be able to determine the exact textural class name from percentages of sand, silt, and clay. In this exercise today, we are going to be estimating the soil textural class using a flow diagram which is found in your laboratory handout on page 4. This procedure will take us through examining the soil in a dry condition, wetting that soil to where it becomes moldable or in a clay consistency to determine how well it will ribbon, and I'll explain this as we get into the actual pan samples of soil, and also wetting this soil to a very saturated condition whereby we will be able to determine the amount of grittiness or sand that is in that particular soil sample. Another procedure that we will do in the lab today is soil color. Now, the color of a soil is a reflection of several different substances which occur in soils. One of the major constituents of the soil is the mineral matter. Mineral matter in the soil will impart a certain color to that soil, primarily based upon the types of elements in those minerals and the degree of oxidation that they have undergone. This is particularly true of elements such as iron. Iron, as it oxidizes, will impart a more reddish, brownish color to the soil. That's an example of that. Other things which will affect soil color will be like the amount of organic matter content in the soil. Organic matter, which is normally found in higher concentration near the surface and decreases as we go down, imparts a dark coloration to the soil. That is because as the organic material decays and becomes part of the humus being a major portion of that organic matter, it becomes very dark in color. Other than the mineral content, the degree of oxidation, and the organic matter content of the soil, if we are looking at the soil to determine color, we also need to be aware of the moisture content of that soil. Soils which are the same soil at a higher moisture content will be darker in color because it absorbs more of the light and reflects less of it than that same soil at a lower moisture content. So when we are determining soil color in the laboratory exercise today, we will be doing this on air-dried soils so that we can have some degree of consistency from one soil sample to the next. After we've determined soil texture and soil color, we will then look at another physical soil property called soil structure. Structure of the soil is how the individual soil particles fit together into semi-stable aggregates or clods. Structure formation under field conditions will be highly variable depending upon organic matter content, the amount of weathering or degree of weathering of the minerals in the soil, the moisture content of the soil, and if that soil has been subjected to tillage or cultivation, the extent of that tillage or cultivation and the size of the structural units. There will be some pages in your textbook that I will refer you to that have examples of structural units when we start to work that particular exercise. So with this introduction, what I would like to do first is the exercise on soil texture. What I'll be doing is I'll be going through 6 different pan samples of soil, utilizing the flow chart on page 4 of your lab, and determining soil texture by feel. We'll first examine pan samples to determine what we can about the texture in a dry state, and then I will be taking a sample of soil, approximately 25 grams, bringing it up to the desirable moisture content, determining its ribboning capacity, and also the amount of grittiness, smoothness, or stickiness that soil possesses. All of these are giving me an indication of the amount of sand, silt, and clay which exist in that soil, thereby determining the textural class name. So with this introduction, let's proceed to the pan samples of soil.